So on page 14, we're going to deal with a slightly different scenario. We're still dealing with another bakery, but this time she's going to expect sales to decrease. Remember, in the previous examples, we were always dealing with sales that increased. For instance, if I go back to the question on number 3, the increase was where we added the 15% more each week. And even in question number 1, the increase was where we added the 10% to the previous jackpot. So far we've only been dealing with situations that increased. Now we're going to deal with a situation that decreases. So the first thing I'm going to ask you to do is to just make a hypothesis based on what you kind of observed and based on what you already know about the word decrease. Make a quick mental hypothesis, and if you can, maybe even pause the video so that you can write down what you think before you just end up hearing it. In letter A, make a hypothesis. What do you think the multiplier would be if we're going to decrease? How do you think that changes the process that we had just outlined in question number 2? Because in question number 2, we said take the initial 100% of what you've got, increase it or add by the percentage, and then convert that value to a decimal. What do you think it would do to decrease? Pause the video for a second. Think about that idea. Give you a few moments. Okay, so let's see if your idea is true. In letter B, it says determine how many donuts were sold 1 week after the debut and use this number to determine the multiplier. What we're going to do is actually a flashback to question number 1. We're going to properly calculate this, and then we're going to see if our hypothesis really is true. So let's make sure we think about this for a moment. She's going to sell 5,000 donuts, but we are going to decrease by 2% the next week. So let's first figure out what 2% of 5,000 is. 2% is 0.02 of multiply 5,000. I would definitely want to use my calculator for that. So 0.02 times 5,000 is 100. So that's how many donuts she's going to decrease by. And if that means I have 5,000 donuts initially, now decreased by 1,000 donuts, or sorry, 100 donuts, then that means that she sold 4,900 donuts this week. Now, let's think about this as a little table. Again, flashing back to the jackpot question, question number 1. Initially, she sold 5,000 donuts. So there's my 0 term. After the first week, she sold 4,900. Remember how we could take a quick shortcut to finding a multiplier by dividing any 2 pairs of numbers or any 2 values in the table? I'll take that pair of numbers, 4,900 divided by 5,000, and that should be able to give me my multiplier. It looks like my multiplier would be 0.98. Now let me just make sure. Again, I'll use my calculator. 5,000 times 0.98. Yep, really is 4,900. So I know that the multiplier is definitely 0.98. Now, moment of truth. Is that what you thought? Did you already predict that the multiplier was going to be 0.98? Because in theory, it is possible, based on the pattern that we've already discussed, that you did actually make that prediction. Let's think about it for a second. If you had started with 100% of the donuts that she was going to sell, she was going to sell all of the donuts. But then the next time she was going to decrease by 2%, it certainly stands to reason that if increasing involves adding your percentage to 100, decreasing would involve subtracting your percentage from 100, and 100% minus 2% would be 98%. And 98% as a decimal, move that decimal 2 places to the left, is 0.98. So if you did kind of figure this out and you're like, well, duh, this makes total sense, then again, that means you can bypass all of this work. You can bypass the table. You can bypass the calculation I did on the side over here. You can immediately read the question and immediately get the multiplier, which means you could essentially skip straight to part C because you'll have all the info you need for the equation itself. You could say T of n equals, because we know it's going to be geometric. All percentage growth questions like this will be geometric. The initial value is 5,000 times the multiplier is going to be 0.98 to the power of n. So sure enough, much more efficient to think about it this way. Now in this one, it says how many donuts will be sold 1 year after the debut. Again, I'm going to think about this in efficiency terms, because if I think based on the table, I immediately discourage myself. This is 1 week's worth, and if I multiply another week and another week and another week, it's going to take 52 multiplications to get me all the way to 1 year's worth of donut sales. That sounds crazy. So if I know that the n in my equation represents the number of weeks that have passed, I can simply take 52 and plug in to that equation. So I can take 5,000 times 0.98 to the power of 52, and sure enough, that is so much more efficient and gives me a relatively good estimate of how many donuts will be sold. Again, you're not going to sell 0.7 of a donut, so you might want to just simply call this 1748 or 1,748 donuts. So in general, if now you feel like you kind of understand how to quickly read a question and generate a multiplier, see if you can put that into your own words in question number 5. In question number 5, we're really just asking here if you can, in your own words, articulate the process. If you read a question, and you might want to use a question like number 7 as an example. If you read that question, how could you get straight to the equation without messing around with a table, without messing around with a bunch of extra calculations? How could you just read the question and know exactly what goes in the equation? How do you know what the initial value is? How do you know what the multiplier is going to be as a decimal? If you can figure out a way of articulating that in number 5, try to write it as some sort of formula or series of steps, and consider even storing that in long-term information in your notes area of wherever you keep your notes in your packet, so that you have something that you can refer to for the long run. So take some time between now and the next video and try to articulate in your own words and phrasing something for question number 5.